we discussed ADA, right? It is a mandatory and it's a much needed phase in the analytics, in the entire process of data analytics or the data science. Next one is predictive analytics, as I mentioned in the beginning, three different: descriptive, exploratory, and predictive analytics. In the whole life cycle of data analytics or the data science project, problem statement, then the model building, then analyzing the data, before that pre-processing, model building, analyzing the data using model, then deriving conclusions. In the entire one, you can repeat again and again the same process, right? If the results, the derived results, are not useful for writing conclusions or deriving conclusions, the extracted knowledge is not sufficient to derive conclusions, or the conclusions which are not useful to take decisions, then you go back to your model, then rebuild the model, and rebuild. After rebuilding the model again, again you derive new conclusions. If the model you have chosen the second time is also not suitable for deriving the conclusions, or the conclusions which are deriving is not useful for decision making, something is required. If that is the case, you go back to the pre-processing phase. You can remove some other noise. Because of the noise, the model is not extracting an efficient patterns. That's why it's unable to derive the conclusions. It's not useful for deriving the conclusions. That's why it's unable to extract an efficient patterns. Then even that is not suitable, you go back to the data extraction. Whichever the data you extracted from the sources is not sufficient to derive conclusions. It's not useful for the conclusion, for deriving conclusions. Again, you extract some other data. Still the data is not useful, then you go back to the problem statement. So it is an iterative process. Again and again, from the conclusions to the model, then model to the pre-processing, pre-processing to the data extraction, then go back to the problem statement, redefine the problem. Like this, you go back and do it. This is the general process. So that the inside the model, any type of analytics, any type of data science model. So let's go for the predictive. Let us concentrate on the predictive analytics. And what are the methods available in the predictive analytics? And large number of algorithms are available. We're not going to discuss all algorithms. Only one or two techniques which are possible to discuss as a part of this session. We're going to see. And the same as the previous session, I'll show you the demonstration. You should know how to implement it. That's why I'll cover the demonstration part using same programming tool. Okay. Yeah, That's what I mentioned in the morning. This is understanding the future. What could happen in the coming
Sir,
days?
sorry to disturb you, sir.
Yeah,
Sir, PPT screen is not visible, sir.
is it?
Yes, sir. Screen is not visible.
Okay, okay. Let me share. I think it's not shared. Huh? Okay, fine. I'll share it. Is it?
Yeah, sir. Now it is visible,
Yeah,
sir.
it's okay, fine. Yeah, this is a continuation of this one. So what I mentioned in the beginning, this predictive analytics helps you to understand the future. And in the future, with the help of the historical data. Use historical data to build the model. Then, after building the model, then you can predict based on the new the attributes which are used to building the model. Again, the same attributes you received, and based on that, you can predict it. Something like, let me give an example. Our academic data only. You take your, this is still an open problem, and you can write your research paper by analyzing the data like this. I want to predict which type of job a student is going to get at the end of BTech degree based on historical data. The history I have, the past 5 years data I have, I'm using how many marks a student is scored in mathematics and data structures, then the programming, okay, and the job, what type of job is going to get in final year campus placements. Who is good in programming is going to get this type of job, or some other subjects. Again, in the program domains, suppose his performance is very good in security, his performance is very good in databases. So programming is good, databases is good, mathematics is good, practical knowledge is good, and is going to get this type of job. Or how much CGPA, how much CGPA or the percentage is going to get at the end. I'm going to predict at the middle only, something like after completion of 3 semesters or 4 semesters. I'm going to predict you are going to get this range. Based on that, you are deriving the conclusions. This helps you to take decisions. No, I don't want my students to get this less CGPA, or I don't allow my students to go without a job, right? So that's why I want to take a different kind of approach. I'll conduct evening classes. I'll conduct a special classes on programming. Special classes on and particular campus oriented, campus placement oriented training programs I want to conduct, because this predictive analytics helping me to take decisions that's going to improve my business, in the sense here the students performance in the campus placements. Okay, this is one simple example where the predictive analytics is useful, and you can apply these techniques. So there are varieties of approaches in this particular predictive analytics are classified into the different approaches. One is the simulation method. You can simulate using a different event, something like the discrete event simulation, and consider the discrete event and simulate the data. Agent-based simulation. Here also we are going to use some simulation techniques and will simulate that the prediction. AI-based techniques, something like neural networks and Bayesian networks. These are some of the type of predictive analytics techniques. And the classification methods are also comes under the predictive analytics. These classification techniques helps us to classify the data. One of the best method is regression techniques, logistic regression or linear regression, the Bayesian trees is also helps us to predict the feature class label for a given one. Parametric methods. In these parametric methods, we are going to consider the different parameters, something like a variables, x variable, y variable. These variables are used to predict the feature. Label for the coming one. Time series forecasting and the linear regression. So using this parametric linear regression, also you can predict the class labels. So here I'm going to cover. It's not possible to cover all types of methods. For understanding, I'll cover this technique, Bayesian tree technique, how to construct and how to develop and what kind of package is required when you are working with this and on one particular data set. Then the linear regression, how this particular linear regression is used to predict the class label, and one data set I will take here and for this particular one, and the demonstration of both linear regression and the Bayesian trees I'll explain to you. The other one is the multi-level modeling is also comes under the parametric, and there also we'll use the different parameters to predict. So let us consider the simple case predicting the class label for a given data set. So let me give one simple example to understand. Even the beginners, those who wants to do the research in this particular domain, and what it's going to predict and how we are going to build the model. Take a simple example. You have a basket of vegetables, right? And you want to classify these basket of vegetables, different classes, class 1, class 2, class 3. With different classes are there. Assume that the 4 different classes. You have a different vegetables, something like this. One vegetable is brinjal. The set of features of these, something like the shape, size, color, and weight are the 4 different features I'm using to identify the class label of each vegetable. So each one having its shape, something like the brinjal. Brinjal having a particular shape and the size is not too big and too small. Then the color is, let me consider the purple, and weight is this some weight, something like a 50 grams weight or 50 to 75 grams is my case. So if the model, I'm training the model, and some other one is, suppose the bottle gourd shape is cylindric and the size is not too big. Some size I have defined, color also I have defined, and weight is around 1 kg or 1 to 2 kgs is the size. Then tomato color is red and shape is round, and weight is something like 50 grams, even less than that, 20 grams to 70 grams is in that. That's the range. Now I have a new item in the basket, or this is the model I have built. My model is this, and it's considering all these features. Suppose I have a brinjal here, and it will verify the shape is matching, then the size, color, weight. Yes, it comes under the class C2. Okay. Then the same bottle gourd is coming. Here it says that the class 3 bottle gourd. Then some other one. A tomato, yes, it is. It comes under the class 4. Is the tomato, right? Now I have an apple. Looks like this. This is the tomato, and this is the apple. Color is red. Shape is also looks the same as a tomato, and something like size is also matching. Then assume that all these are comes under vegetables, and inside that the multiple classes. Now I have an apple in the basket. It says that tomato because it's matching. What is that? 80% is matching. And out of 100, my model is able to classify all the items in the basket except 1 or 2 or 3. This is an error rate. Error rate in the, that means unable to classify few. What is mean by what we are predicting here? We are predicting class label. What type of class it is? Something like a vegetables and fruits. Inside vegetables, the different types of vegetables. Okay, that it's unable to classify. It's unable to predict the class label. That's an error rate. Based on this, we'll decide the accuracy of the model. So what is required? My model is unable to classify with these parameters. What are the features I have extracted from the data set are not sufficient. These are not sufficient to predict a class label for few items in the data set. So what I have to do now? I need new features to classify the data or to build the model. Then when the new features are added, right, then it may able to classify. This improves the performance of the system, performance of my model, whatever the model I'm building it here in this particular problem. Okay, this is the predictive analytics. Let me go for a few one particular algorithm or two varieties of algorithms which are used. Let us see the data decision tree, what I explained to you just now. We are going to use decision tree and regression techniques to classify the data. This is a flowchart kind of a tree structure data, tree structure model. That's why it is called as the decision tree. Each internal node in the tree is called non-leaf node, denotes the test on an attribute, particular attribute. Some internal nodes. Assume that this node is, these nodes are internal nodes. These are non-leaf. Each branch represents an outcome of the test. These are the branches. Outcome of this. Outcome of the test. Where we have the test here in the non-leaf nodes. We are testing something. You're testing that. And whether it is a passing or not. Just now I give an example, basket of vegetables. Different features. Very first feature I'm considering the shape. Okay. Based on the shape, I have multiple branches here. Okay. It will go into one particular branch. What is the shape? Shapes have 1, shape 2, shape 3, shape 4. One vegetable V1 comes under shape 2. This is a round shape. Okay. Then again, if the shape is round, I'll test a few more conditions here. Then based on that, what is a type of one gives. So each branch, these are represents the outcomes of the test. And each leaf node, each leaf node or the terminal node holds the class label. So starting from the one, right, different levels are there. Not exactly the same levels, maybe 2 levels, in this case 3 levels, here 3, here 4, like this. I'll go for test 1, based on that I'll reach 1, then based on that here I'm here and I'll test some condition here, and based on this I'll go for some other one. Then it's passing this test and it's reaching, then again I'll test it and I'll go for this. So here the class label is different, not exactly one, the multiple are there at each level, right? Then I'll reach one path from the beginning, I'll test multiple conditions, I'll reach one particular location. That is the class label, which holds the class label. Okay. Topmost node is the root node. That's what the first node is, the starting node. Base condition, we'll use it here. It is mostly used in the data mining and the learning applications and data science applications. That's what. I don't want to these different. It is there are a large number of applications predicting email spam and tumor cancer and the loan is good. Or, okay. And in this particular one, to build the model, whatever the data we are using to build the model, that data is called training data set. That means observed data. Whatever the data you observed, based on that you are building the model. Okay. Then the next time you are, and based on this you build the model. You train. So just now again it's a basket of vegetables. I trained my model based on the observed data. I have only up to the first version have only the one round shape, that is our 2 round shape. One is tomato and another one is the brinjal. Both are looks the same shape, assume that. And the new one is apple is the fruit, and also it looks like the same shape as same as this tomato. Now these two, this one is, well, it was not exist, and now it is exists. So building a model based on the observed data, that is called as the train. And we need to validate the model. So that purpose we'll use a validation. So this data is called the test data. Set of validation data is used to verify and improve the model. So set of predictor variables will find in the data set in this particular model decision tree, this model to arrive at the decision in the category kind of one. Yes, no, acceptable or not, spam or not, or some other one like that. Let me give a simple example. Simple example. You have a market basket analysis data. Okay. And you want to, you have different customers, customer 1, customer 2, customer 3, customer 4, set of customers. So you want to classify what type of customers, or you want to understand a customer is capable of buying a computer system or not. Based on that, you are going to take a decision. What is that? Give some discount and attract those customers who are able to buy, who are capable of buying a computer system. So what are the attributes are considered here? In this case, one is the age attribute. Then another one is, in age, there are three different variables, or three different values. Age is classified like this: youth, middle-aged, and seniors. Now, you are building the model. Now, at present, using a training data set, you are building the model. In your data set, there is a one row. In this row, age value is there. Age value is middle age. Okay, age, and the something like the different types here: youth, senior citizens. Middle age, class label. Let us consider the label. Label is yes. Okay, that is the label. Yes. Some other row, age is youth. It's not sufficient. One more row is required here. One more column is required. That is student or not. So student, not student, student like this. Yes, is the student, and not a student. Yes, and like this. Now, what you are doing? You are considering set of tuples to compare, to construct the model, to construct this decision tree model. Now, you're deciding here age factor you are considering, and deciding what type of person is a middle-aged, yes, capable of buying computers, but not middle-aged, is youth. Again, in the youth column, I have student, yes, no kind of options. Student, not student kind of one. I'm testing, is a student? No, is not a student. So it's not going to buy a computer system. No use to send a message to him, and no use to you offer to this particular guy. Whereas the other guy is a student. Age is youth and is a student. Yes, is a student. I'm going to, yes, chances of buying computer system is more. My model says that. During testing, I'm going to test like this. I'm building the model. In my class label, Student is a youth, yes, it is there, yes is there. Is not a student, n is there, no, is not going to buy. This is the predictor column. Okay, then age is senior citizens, age is senior citizens, then the chances of buying, see, age is senior citizens and the credit rate is, that's not sufficient to decide whether he is capable of buying computer system or not. I'm testing the age, what is the credit rating? The credit rating is good or not, fair or excellent. In my, you can take a good, bad, or average, very good, like this. You can take varieties of additional values in your case. Is credit rating is excellent, then the chances of buying computer system is very high. Then immediately, if I got the data like this or the class label identified for a particular person, then I'm going to send a message immediately. I'll give a 10% discount if you are a student interested to buy computer. Yes, I'll give 10%. Yes, if you are interested to buy within this week, I'll give a 15% discount. Then like that, you can send a message. So here, this model is predicting class levels, and based on that, we'll take a decision, and that improves the business. Okay, this is the general a simple technique, a method, but it's a popular, used in many applications, used in many applications. But let us see here how to implement this one using a particular package, and how to write code, and how to test, how to predict class labels for one particular data set. So here, I what I'm using IoT data. This is my data set. I have collected it from my department lab, IoT lab, and some of my colleagues are working on the IoT devices, and I have collected data set from them, and I'm using this data set for predicting the class labels. Okay, so I'm going to construct the decision tree, and I'll predict the class labels, and I'll test it. At the end, I will see whether my model is able to predict all the class labels. What is the error rate? Error rate, that means the accuracy of my algorithm on this particular data set. That I'll show you to you how to load the data, how to build the model. See how to loading the data, then building the model, then that's what the decision tree construction, and testing the model, then accuracy calculation. So in every all these predictive analytics cases, the data set D is divided into two different data sets, D1 and D2. D1 is the training data set, and D2 is the testing data set. Training and the testing data sets. So two different data sets. And using this, I'm going to build the model, and using this, I'm going to validate the model. Validation. This is building the model. Okay. Oh, yeah. Let me show it to you directly. The demonstration one, I'll show it to you. Let me open the demo file. Yeah, let me explain the code here for this decision tree construction in predictive analytics. Decision tree construction. So here, this is the OR environment. Those who are first time using this is the R console, and this is the GUI, R GUI I'm using, and this is called as the base, base R. Okay, then what we want to construct a model, predictive analytics model, that is the decision tree model we want to construct. So if you are using other programming tools, you can, and if it is available readily, you can use that, or else you can build your own code. Especially when we were doing this initial stages, many times we have written code in Java and C++ many times. But these programming tools helping us a lot, and without worrying about the programming, you can concentrate on the model building. Then you can build a model, and with a few modifications in the code, you can build your own model and you can implement that. When it comes to this decision tree construction, there is no package. So the package does not exist. That's why we need to install new package. So new package installation is required. What are the packages are supporting this one? Something like this, the way of installing packages, install.packages, then this is the name of the package. See, the beginners, those who are doing this first time, those who are attending uh, this particular programming tool, those who are not familiar, you can visit this website, and here we'll find all the packages which supports for that. So if you want to install, you go to this cran.org project.org. Here you will find the boundaries for that. You can install which this platform you are using. Based on that, you can choose and install that. So coming to the packages, the left side in the bar, there is a packages button. If you click on this, you will find the table of available packages sorted by date of publication. So here, the list of packages are available. So just to do the searching, decision tree construction. Decision tree. See, the variety of packages, 11 packages are identified. One is a tree hit R, is a heat map integrated decision tree visualization, and decision tree, this is a C50, a rule based model, and a CAT, then the split sorting, and these are the varieties. Like this, there is a DT tree, and there is a package called RPart. So this particular one is recursive partitioning under this tree construction. This one is used, decision tree construction. Okay. So using this, you can predict a class label, and this package I'm going to install in my system. Okay. But already I have installed, and two packages. One is r.plot is required for the visualization, and one for model building. So these two packages already installed in my system. I am not executing this because when I'm executing again, it's going to connect to the live mirror, and every time it's going to connect to the live mirror and fetch the data or this package details from the mirror, and I need to install. And Just to verify that, I'll do this too. If it is already installed, it says so no errors. So look at this too. What I'm doing it here, uh, library command is attaching to the environment, something like a import statement in other programming languages or include statement in other programming languages. So this library, so no error means already installed, successfully installed in the system and attached to the environment, right? So once that is done, these are the sequence of steps. Identify the particular package based on your data set, based on your model. You choose the appropriate package and install that package, then attach the package to the environment. Then after that, once the package is successfully installed and attached to the environment, then get the get the data set into our environment. There are varieties of techniques to read the data set. Let me read that. This is one method. I'm using it here to read data. So read.csv in the same fashion, but how we have extracted data in the morning for morning session, the same way. So reading data, read.csv and file.choose. What I'm doing it here, I'm putting a comma separator to separate the data in the data set. So before reading that, let me show you the data set which I have and look at the data set, because the human inspection is much needed at the data set side in the beginning before building the model. Uh, so let me show you the data set. Look at the data set. Just a minute. What are the attributes are there in this data set? This is the session ID data, and these are the different parameters they considered in the IoT lab. This is the IoT data set. They are monitoring the level of COT in that particular CO2 in the particular location where this IoT device installed, and the smoke level, then the light, then the temperature, then there's the time recorded, and the time level. So I'm not looking into the units. You can choose any units, and it's not an important one, right? So only thing what I have considered it here, one is the temperature, only the temperature attribute. I have not considered the multiple class labels. Multiple attributes to predict the class level for the this one attribute. What is that? The temperature level attribute. This is the class label. So in this case, only one particular attribute is used. So it's a manual class label. So I have labeled the class, this temperature level into 4 different classes: A, class B, class A, uh, class A, class B, class C, class D. 4 different class labels. And these class labels are identified based on well, these class labels were assigned to the label class attribute based on the temperature. See, something like if it is less than 80, class C. Something like 80 to look at 90, maybe 90 or 100. Assume that 80 to 100 is class B, 100 plus is class A. Then let us see a few more classes. So C and D, C is 80 below, above 50. Assume that 80 to 50 is C, below 50 is D. You can add a few more class labels. These are all yeah, there's a 4 different class labels are there. So I'm building the model based on this, and I'll show you how to verify this. Yeah. Uh, so what we need to do, we need to extract the data set first. We need to load the data set into the environment, then inspect the data set. Let us do one by one. This is reading data set into the environment. This is the data set I'm using. DT class is my attribute, my object in the R after extracting data from that. So inspect the data. Inspect the data to classify using decision tree. This is when you are looking at that, the object will get the data set. This is the data set. Okay. Then when you are doing this, this is the one. Because many columns are there, many rows are there in this. Approximate rows are 500 rows are there. Uh, Out of this, I want to see what are the column names I want to. Session ID, CO2. This is the smoke and light, temperature, and recorded time when it was recorded, and the temperature level. These are X, and these are all the additional. We don't want those one. So let us remove those. 1, 2, 3, 4, 5, 6, 7. Total 7 columns are there in the data class. Okay, is equal to data class 1 to 7. I want 1 to 7 only. So now let me display. So now these additional columns which are appearing. When you are looking at the data set, see that column is not appear here. It's not there. Or maybe due to this data, additional columns are part of this. So that's why we considered only A, B, C, D 4, E, F, G 3, total 20, only 7. So 7 are considered and all 7 were displayed here. Now after inspecting the data set, you can divide the data set. This is the standard procedure we follow in all predictive analytics. Divide the data set into two parts. So one part is training part and another part is the testing part. Okay, so data is divided into two different sets, that is the training data set and testing data set. See this, how do you divide these data sets in predictive analytics? How do you divide the data sets into two different, what is an approach? So it is very difficult to decide and very difficult to generalize. So it varies problem to problem, data set to data set, model to model. And many researchers published optimal data division, something like 60-40, 60 for training and 40 for testing, or 40 for training and 60 for testing, kind of one. You can take any size, there is no issue. Here in our example, we are considering out of 500 samples, we are considering 200 samples for training the data set model and 300 samples for testing the model. Right. Suppose so first I want to extract first 200, 1 to 200 rows. All these 1 to 500 rows, if you are extracting 1 to 500 rows, you will get only few class labels. There is a chance to miss few class labels. Maybe those are the entries for those class labels are appearing from 201 onwards. You got it? What I'm saying? Dividing the data set based on these two sets, training and testing, a biased approach, that is the first 200 tuples part of training, whereas the remaining 300 tuples from 201 to 300 row is what is that, the testing one. So this one creates a problem. What is that? Sampling is the what is the biased one. The division is a biased one. That's why to avoid this problem, we'll use a sampling technique. This sampling technique is the random sampling technique. So we'll use a random sampling technique to divide the data set into two different parts. So we are going to create a sample with 200 records. 200 records. Look at the example. So this particular portion of the code, what is it? It takes a 500 samples as an input, and the next two sorry, yeah, 500 as an input, and out of that 200 are what the 200 records we want. Let us execute this, and it's not exactly on the data set. This is just like an index, hash values kind of index type of one. Simply you assume that the index values. Look at the data sample. These are all the locations. See, 220th record I want, 4th record I want, 407 record I want, 167 I want, 382, 7th record, 12th record, like this. The total how many records are there? 200. See, this is 193, 4, 5, 6, 7, 8, 9, 10. That means total 200 samples. These are all the indices. Now what we are going to do, we are going to extract data from the data set at these locations. These rows are part of my training data set. Okay. So read the data set. It is already done. Then split the data set into two different parts. One is the training underscore data, and another one is test underscore data. Okay. So one is the DT class underscore training, from which this is from a data, an object. That object consists the entire data set. In this one, locations at this scalar locations. See, what are the scalar locations? 200 samples out of 500 samples at these locations are a part of my training class. Now, the same data, I'm using the same data set as an input, that is the data class. And in this data class, something like other than those locations. What are the locations? The locations which are listed here in the training data set. In this one, these are all the indices. Other than these locations, we want as a part of training class. Then after that, we'll build the model. Let us uh, do this, dividing the data set into two different. Then see, look at the data set. See, these are all the rows. 27th row extracted, 476, then 67th one extracted, and so on. These are all the different rows, and the different that the all these rows are part of this data. What is this? Training data set. And the data class. Data class, the testing one. Other than these locations is the testing one. Let me execute this. So all the locations other than the locations which are listed there are part of this. See, look at this. One is there, one, two is there, three already part of training data set. 3, 4, 5, 6 is there, and so on like this. See, 100th one is there, 101, 102 are part of training data set. So up to the last one. The last one is 499, 96, 97, 98, 99 are in the order. Okay. Now, I want to build the model. To build the model, I need this function. This function is available in the RPath package. So you need to install the package and you need to attach the package first. So look at this particular one. In this DT class is my object. That's my model actually. The created model I'm going to store in the object called DT class. Okay. Then this portion RPath is the name of the function, and inside this is the formula. What is that formula? What are the attributes you are using to predict the class label? So one variable I'm using it here. Multiple variables you can use. In case of multiple variables, comparing this one with the attribute 1 plus something like CO2 plus you can use other attributes. Let me see what are the attributes are there in this one. So what I'm doing to predict the class label, I'm using the temperature. In addition to temperature, there are smoke, CO2, light, and other attributes. So here I'm using only one because the class label is depending on one attribute only. So our part is inside this. Compare. This is the formula. First parameter is the formula. Then the second parameter is the data set. This is data set. So this is the data set, and which method I'm using it here in this particular function. What is the method? Is the classification method. Method is equal to class. So with these parameters, I'm going to build a model called decision tree. Let me execute and show you the decision tree constructed. Say no error means successfully executed. Then this is the decision tree. Constructed decision tree is shown here. At the one first label, class label. Look at the class label. The first one, root is 200 because we have taken 200 samples. Okay. Then out of this, a testing condition at root level. So in the decision tree, different levels are there. At each level, we are testing one condition at the node level. And these branches are outcome of the test. If the condition is greater than 90 to 95 out of the 200 samples, 95 samples comes under class A. Then it is less than 92. How many? 105 are less than 92. This is the input data. But one more level is there. Multiple levels are there in the tree. If the temperature is less than 92.05 and the temperature is greater than 80.32. So if the temperature is greater than 80, less than 90, the label is class B. In the range, what is the range? 80 to 92 range. comes under class B. How many such samples are exist in the data set? 105 samples are there in the data set. Then in this 105, 37 samples are of type is B. Then the 68 are the remaining samples. So this 68 and 37 total 105. Then in this, so that means the temperature is 80, 92 to 80, class label B. What about less than 80? Less than 80? Unable to decide. Again, the less than 80, one more condition is there. Less than 80 but greater than 44 comes under C. How many such samples are there in the data set? 20 such samples are there in the data set. What is out of 27? 20 are this. Then greater than this, the remaining all samples comes under the data set or the what is the in the decision tree. This is my decision tree. Okay, let me so it's a difficult to understand when you are looking at the results like this. That's why what I'm doing it here, I'm using an additional package called rpart.plot. This one helps us to plot the data set. Let me execute this command once and yeah, look at this. So when I'm executing this, I can say the data, the visualization of the decision tree. See all these values greater than 92. Yes, the condition is true. Total how many are there? Out of 100. Here, let me use the other one. This the second method is good compared to the first one. Yeah, this is one. So here total 95. See, look at this. Out of 100%, 295 are class A. Then in this one, 37 is class B. Then after that, the 27 are class C. Then all remaining are comes under class D. So greater than 92, then greater than 80, and the this is greater than 45, and the less than 45. Four different class labels. Okay, then this is not enough, this is only the training data set. After completion of construction of the model, this is our model. We need to test the model. How do you test the model? With the help of the validation, data validation. So we have the validation data here, that is the testing data. So let's go for testing data set and test the model to see the accuracy of the model. This is the function is used for predicting the class labels. Sorry. So I'm predicting the class label. For that, I'm using a function called a predictive. This function takes decision tree as an input. Right? Two input data sets. One is the existing tree, and another one is testing data. So in something like an internal implementation for each row in the test data, set of attributes what are participating in the decision tree, take the value of that and compare with the decision tree. Go to the root and test with the values, the different conditions at the different row, nodes, non-leaf nodes, and reach to the bottom of the tree, that is the class label. So this is the decision tree. This is the test data and the type, what type of method you want. The type is the class label prediction 1. Let us predict that. successfully predicted. See, executed. There is no error means successfully done. Look at the P. So this is the vector. What is this P? P after prediction, every tuple, what I explained to you, every tuple in the test data and compare the values with the take that attribute values and search for the class label in the decision tree. After searching that, first row is C, second row is also C. It means first few rows are type C, the next rows are type B and A and so on like this. So in the vector, output values are stored in a vector and how many levels? Levels in the sense how many class labels are there in the data set. In the training data set, 4 different labels are there. But this is not enough in case of large data. When you are building a model for the large data and testing the model, we'll get the large number of tuples. But what we need calculate the accuracy of the model and other parameters. You can, with accuracy is available, you can calculate other F-score values and other types of values you can do. There is no this one, what is limit on that. You can go. So now what I'm doing, I'll show you in the tabular format. This is the confusion matrix. I'm creating the confusion matrix. This is the this table. See, and that P. This is I'm creating the table, and in this table there are 4 different class labels: A, B, C, D, and A, B, C, D. So rows and columns are A, B, C, D label. See, 128 out of 300. Please remember the total number of samples in the test data are 300. Out of 300, 128 are the class label A, and B type is 65. Then C type is 30. Then D type is 46. Only a diagonal. AA, BB, CC, DD are these. See, 29 samples. Few are C type and few are C to D, and this is C to D, total 29. Then this one, out of 330 samples are unable to classify. Why? Because that's the model error rate in the model. Unable to classify that. How do you calculate the accuracy if you're unable to classify the model? For this prediction data, let's calculate the accuracy. See, I have created a function to calculate the accuracy. So this function, what does it, this is the name of the function. What I'm doing it here, sum of the diagonal values. That means correctly predicted values. Divide with all the values. How do you get all the values? This is the each row, how many samples are there? Sum of all these samples, it gives me the total number of samples. Then that one multiply with the 100 gives the accuracy of this. Yeah, let me execute this. So the accuracy is 89.9%. Okay, 89.9% is the accuracy. So we can say the model is able to classify this much percentage only. Okay. And at this point, I want to mention another important thing is you may not get the same accuracy if you are re-executing again. Let me show you and explain what is the reason behind that. Let me construct starting from the model. starting from this location. See, remember that the now 89%. I'm re-executing again this. Then reading is not. Then training, then constructing the model. This is the visualization. Let's go to the model prediction and the accuracy calculation. Let's go to the accuracy calculation part. Say 92%. Previously, it was 89. Now it is 92%. So previously 30 samples were unable to classify. Now it is 18 plus 5. It is 23 samples are unable to classify. So previously A type was less. Now it is a bit more. Because the reason behind this is this here I'm using the random sampling technique. This random sampling, the sample created using a random technique. So that random technique selects the tuples randomly. So previously selected tuples were different, and excuse me, Bharat, please mute your mic. Bharat, please mute your mic. Okay, right. So what is the reason behind this is the random sampling. So the random sampling is because of the random sampling, it's unable to. So every time I'm getting the different class accuracy in the classification, in the prediction of this. The what is that? The accuracy. What is the prediction of the data set? So in the same fashion, you can go for the varieties of data sets. You can choose, this is one data set I have chosen. You can go for the other data sets if you want to do it. In the same fashion, you follow the same sequence of steps which I have shown to you. So in the same fashion, you do one by one, then verify the accuracy of your model. So like this. So iris dataset also you can use the iris dataset, and that I'm not going for one more dataset. Like this, you can take any dataset and classify the class labels, identify the class labels for that using this Decision tree technique. Let me go back to the PPTs and see what is missing in the PPTs. Yeah, these are all the models I have taken in it, and yeah, like this you can visualize it. How many class labels we got. So when you are plotting that, this is another way of what is this P. So when you are plotting it, we'll get the different sizes. See, class A size is more and class B size is less. C is also very less and D is there with more when compared to this. So understanding what type of classes, how many classes are there, how many class labels are there in the training testing data set. Like this, you can do this. Then, yeah. So that's what I'm not covering this iris data set. So in the same fashion, you go for, just let me show you the sampling here. Out of 150, I'm taking 50 here. Then the same as that, you divide into two different, and only one thing is here. Look at this. Uh, So in the data set, this is the class label, one variable which consists the class labels, like our temperature column. This is compared with all other attributes. Just a tilde operator means If we want to compare the class label with all other attributes which are there in the data set, then directly use only comparison operator, or else attribute 1 plus attribute 2 plus attribute 3, something like this. Attribute 1 plus attribute 2 plus attribute 3. Like this, the multiple attributes you can compare is a tilde operator is used of that, and then create, build the model. Just build means all other.
34 వచ్చింది, నా 31 వచ్చింది. లేదు సార్ చూపించాను. ఓవరాల్ అటెండెన్స్ ఉంటుందా? అదే జస్ట్ డేట్లు ఉంటుంది కదా సార్. ఇప్పుడు మైండ్ పోయింది సార్ వినంగానే. ఆన్లైన్ అటెండ్ అయ్యాము, డేట్లు ఏమి ఉండవు.
ప్లీజ్ భరత్, ఎక్స్క్యూజ్ మీ,
ఏ ప్రాణాలకు 56.
ప్లీజ్ మ్యూట్ యువర్ మైక్.
నిజంగా ఇప్పుడు దా కాలేజీ రాని వాళ్ళకి 65 ఎంత ఉంది. రషీద్ అని నెంబర్ చెప్పాలి.
Participants, please mute your mic. Sir, please continue, sir. Sir, you have muted yourself, sir. Ramakrishna, sir. Please unmute yourself, sir.
Oh, sorry. Okay, fine. Thank you. Let me show you back again. Yeah. That's what in the linear models, x and y, two variables, one is an independent, another one is a dependent variable. So y is depending on x variable, and based on that we are going to predict the values for y. That is the continuous quantity. If you want to predict the continuous quantity, this model is best. And one of the best model is for this linear continuous prediction, a regression. That is, the linear regression is one of the simplest form of the regression model. One is the predictor and another one is the response variable. So independent is the predictor and the dependent is the response variable. Look at the diagram here. these are the different points which are placed on the two-dimensional space. So in this two-dimensional space, x is an independent variable. So these are all the, when x is varying, how these values are coming, how these y values are coming, like that. Now this all red color, all the points are the points when you are comparing these two, when you are plotting the data for these x and y variables. Now on this one, what I'm going to use a simple line. It is a linear regression line. So this is y is equal to b naught plus b1 multiply with x. X is an independent variable, and E is an error rate. So x is an independent variable. What we are trying to predict here, value for y based on the x values. Then the y is the response variable. That's what I mentioned, the class label we are going to predict for this. So b naught is the intercept at one particular line. When you are drawing a linear line based on the linear model, the linear regression model, when you are drawing a line, that line is going to intercept the y-axis at one particular location. That is the b naught. And b1 is the slope. Slope in the sense here the degree with the x-axis. E is the standard error. Let me explain all those variables here. X is an independent, y is a dependent variable. So y is equal to b naught plus b1 multiplied with this plus error rate. Let me explain one by one. So one is an intercept. So this particular green line, so this green line is going to intercept at this particular line here. This is the b naught. It's going to intercept. And the angle when it is intercepting, the angle between these two is the theta. That is the b1. Then multiplying this with the x. That's what. B naught is the intercept and B1 is the slope and residuals. See the error rate, this is the residual. What is y1 is the value, this is the y1 minus this is at this particular line, it's a touching. Okay, from here to here in y is equal to set of values in this y1, y2, y3 and so on. It is a vector of values. In this vector of values, a particular value, this is y1, yi. Suppose this is y1, y2, y3, y4, y5, y6. See, capital Y6 is the sixth one, and this is the value and it's intercepting. Suppose x is here 20 and y is here 35. So 20 comma 35 is the actual intercept location. Look at this intercept location. Okay, at the here the point from x and y both are touching to this line. So 20 comma 30, but this value is there at this location, something like a 30 comma 20, 20 comma 30. Instead of this is actual value is this, okay, and the predicted value is this. Okay, just understand the predicted one. Later we are going to predict this portion of the data based on this portion of the data. But this is when you are looking at these values, it looks like this is the predicted based on the regression model. these are the actual values. So what is the residual here? The error rate is, this is the error rate. So plus E1. So this here the vector of values. Based on that, we are going to that's the continuous y values are predicted based on these x values. Got it? Uh, 1 minute. Yeah. Right. That's what the till now covered all these portions. Touching point and error rate, then the set of y values and these values, and based on the x values extracted this. So with this the theory part, let me execute this and let me show you how to predict. But let me explain which portion. See, latter based on this, these are all the predicted, right? Y is equal to this, and this is the predicted one, and this is the actual one. In the same fashion, I want to predict for the future. Assume that this portion of the data, I want to predict it. Okay. So this is the historical data, history of the data. And this is the future. I'm going to predict for future. How it's going to happen based on the x values, what are the y values at this location. And these are the locations. So it's going to extend this. So drawing the curve and drawing the line, linear line. Say sometimes the error rate is 0. Oh, in the beginning I mentioned error rate is 0, the variance is less. When it is 0, if all the values, say in this one, in the linear model, this is my car, this is my car, all the values are on the line, exactly on the linear line. That means there is no deviation from this. That's why all the error rate is 0. So the predicted values and the actual values are same. So it's going to predict it. So if the error rate is more, this you can adjust it. Suppose more values. Let me cancel it and again. Yeah. Suppose more values are this side. See, like this are there, this linear regression fitting the best curve. So what I'm doing, what it's going to do, based on this value, what is this, the the degree from here to here, this a b1 value is going to change. Now assume that it is a 45 degrees. Now we're going to change it. Instead of that, it's going to draw a line. This is 40 degrees or something like this, 30 degrees. Now this is, so it's going to predicted values are like this only. And here predicted values are this, or sometimes the predicted values are this and this portion of the data. So when these values, when it is increasing the I value, when days are going like this, so it's going to predict at the linearly the high values of y based on the x values. So here less values. So this is when it is horizontal to the x-axis, these values less something like this, parallel to the x-axis are it is exactly 0. That means this horizontally it's moving, and this is about the one. And let me show the code. And yeah, I don't want to. Yeah, what we'll find in the function coefficients, residuals, and fitted values, and residual values will find. Let me show this. So LM function is used. Wait. LM function is used for doing the linear model, for building the linear model of this particular prediction analytics, predictive analytics. LM function is used, and in this one we'll find the vector of coefficients, and those are all the coefficient and the residuals, and fitted values, fitted mean values, and df dot residuals, the residuals degree of freedom to fit the line. Okay, and p-value is the prescribes the p-value, and it is used to test the hypothesis, whether the hypothesis are passed or something like this. 0. p-value is above the 0.5 and it is a passed, and the other cases failed kind of. And you can choose your own approach to test the hypothesis. Let me go to the implementation. Let me show you how to do this implementation. It takes less time. Okay, open the script. So here, look at the code. I'm using air quality data. This data set is already available for demonstration purpose. I'm using the existing data set. This data set is available in the R environment. Okay. We want the data function is used to read the data, and the names, these are the list of these are all the names: ozone, solar, wind, temperature, month, day. These are the attributes in the air quality data set available in this. And just plot the air quality, ozone, because we are using ozone for the for building the model. Right, and when you are plotting it, the ozone values, see these are all the values. The index values are 1 to 150, and this the air quality is something like about 50, and here 150 plus the ozone values, and maximum cases when the days are increasing, and it is about 50. Okay, then direct just plotting and looking at that. And what I'm doing it here, I'm calculating the mean value, because the based on the mean value, I want to draw a line. Okay, that is the absolute line, and after that I'll build a model, linear model, and I'll show the difference between these two. So what I'm doing it here, I'm calculating the mean value of this particular attribute, mean of air quality of this, and remove all the true values of this. Then after that, I'm drawing an absolute line. Horizontal is equal to ozone, mean value of this ozone. When you are drawing this, so mean value is this. See, mean value of this is around 50. Less than 50 is a 48, 49 is the mean value of that ozone. But here we want to predict not based on the mean value, it's based on absolute. This is the linear model. So for that purpose, first I'm building the model, linear model. To build the linear model, I'm using this function, linear function, and ozone is the attribute I'm using. I'm comparing this one with the solar.r. Okay, solar.r is one attribute, and comparing this one with the ozone attribute. I'm not using other temperature, wind. I'm not using. I'm using only this particular one. In which data set it is? It is air quality data set. So in the air quality data set, and storing the data values in the model. Name of the model is this. Let me execute this. So model is successfully created. Linear model, regression model created. Let me draw an absolute line based on a model. Okay. Okay, just a minute. Let me plot the air quality first, then build the model. Then try an absolute line based on this. Yeah. See, this is the linear model. I'm predicting using this particular one. These are all the differences which are coming from this. The error rate. So this line will fit based on the less error. How it's going to draw a line based on the residual values. It calculates some of the residuals, and when it's going to best fit. So it will adjust this the degrees with the horizontal line x-axis is going to adjust like this. This something like this. So this one something by increasing the degrees. So what is the residual values? If you increase more, error rate will come. Then decrease it, decrease, and then at one stage you will get the less. So this line means the minimal error rate, and beyond this what are coming are the part of the predicted values of after all these things. Then the after drawing a line it's going to predict it. And these are all other models after drawing it and controlling it. Then it is ready for varieties of levels, the mean values, and fitted values, then with the standard error rate. So after normalizing that, then we'll get the this kind of one. Then this is the between the residuals, standardized residuals, and the fitted values. Okay. These are all other additional parameters, something like the Cook's distance and other things. Then term plot, use it to plot the data set. So this is a quick norm, and it's plotting like this between the solar R and solar R. The values are like this. Yeah, this is what that the predictive analytics. Under this, what I mentioned in the beginning, there are a large number of methods are exist. So just covering all this instead of covering the depth of this breadth of the models, and better to cover the depth of the model in that fashion, have taken few examples and explained based on the practical approach all these the two different methods explained. One is the parametric one and another one is a classification one, and you have AI based methods. Then other methods are also the simulation methods. So those methods are also what I mentioned in the beginning. You have packages. Only thing is you will get the theory from textbooks, but the practical is required. So go to the packages list and what type of classification technique you want to do. Then based on that you search for the package and install the package. Then work with the pack. Then build a model based on the examples. One important point I want to convey here, in every package you will find some examples. Go through the example, build the model based on the example, or test with the example code. Then once the example code is tested successfully, then you can go for your own data set. You can choose the data set and build the model based on that. Okay. And here I mentioned two. One is the decision tree and then linear regression. I have taken a simple linear regression because only one attribute I have taken. You have multiple. You can go through the multiple attributes. These independent variables. That means predicted values depending more than one attribute. So you can choose multiple attributes and compare with the multiple attributes, and you can predict the values based on that. Okay, this is about the predictive analytics. So before closing, I want to take questions from participants. So any questions?
Thank you very much, sir.
Thank you.
Wonderful session. And I request all the participants, please ask the questions. You can post your questions in the chat box also.
Also, yeah, later also you can ask questions if you want to. My details, you can contact me if you have any questions. Later also you can. This is my official mail ID and this is my number. You can contact me later also in this particular. So if you are doing the research in data science, data analytics, machine learning related, this kind of practical approach is good, and you can use this tool for your future research. And if you have any queries, you ask me later also. Okay.
Sure, sir. Thank you, sir.
Okay. Thank you, ma'am.
Thank you very much, sir. And dear participants, please join the session 3 by 2 o'clock. Thank you, everyone.
Okay. Thank you, ma'am. I'm exiting.
Thank you so much, sir.
Yeah.
You can leave the session, sir. Thank you so much.
Okay. Okay. Thank you.
Dear participants, you can leave the session and join the session 3 by 2 p.m. Thank you.